Good morning, Eva.
Good morning, Tithi. How are you?
I'm fine. What about you?
Yeah, I'm so. Okay, let's start.
Okay. So, should I first start?
Yeah. Okay.
I'm sharing the screen.
Okay.
So, it seems you need to permit me.
Yeah.
Thank you for your permission, Eva.
Can you share now?
Yeah. Eva, is my share is visible?
Yeah, I can see that.
Okay. So, I was assigned problem 5.4. It was on excess demand in Cobb-Douglas preference.
Hmm.
So, can you see the question?
Yeah, I can see.
So in this question, we can see that there are two consumers, A and B, and two goods, and their respective utility function and endowments are given.
Yeah.
So both these functions are Cobb-Douglas preference. So
Yeah.
in the first part of the question, it is asked to find the Walrasian demand of A and B. And in the second portion, it is said that choosing good 2 as numeraire, graph the excess demand for good 1 as a function of P1. That means, I think in this question, I need to put the value of price of good 2 is equal to 1.
Yeah.
And the last question is calculate the competitive equilibrium allocation and verify that this is the point where excess demand is 0. Okay, Eva, I'm going to the solution.
Yeah.
The first part, finding the Walrasian demand. So this question can be solved by multiple ways. You can solve it by using the utility maximization problem, then forming the Lagrangian, then solving it, and then the later procedure. But I have used a shortcut way. You can say this is a shortcut way. So I derived the marginal rate of substitution firstly, and
Okay.
evaluate the price ratios. We know all the basic. Do you know that?
Yeah.
So we everyone know that the marginal rate of substitution is the set of all Pareto efficient allocations. And all the Pareto efficient and all the Walrasian demand is Pareto efficient. We know that from our welfare theorems.
Yeah.
This is well discussed in our chapter 5 assignments, presentations, class lectures everywhere. So I think you get it.
Yeah, I get it.
So first part for consumer A, we are deriving the Walrasian demand for consumer A. So from the utility function, we can derive the marginal rate of substitution by using this formula. Using this is the formula of marginal rate of substitution for A. So after using this function, so putting this function into this formula, we can derive the marginal rate of substitution for A, which is gamma divided by x1A divided by 1 minus gamma divided by x2A. And after doing the calculation, we have reached into this point. The P1 x1A is equal to gamma divided by 1 minus gamma into P2 x2A. This is the normal calculation. I think when you see it and do it, you will easily understand it. Then this is our equation 1. So we can use this in deriving our budget constraint. This is our budget constraint where P1 x1 plus P2 x2A is equal to, which is our expenditure, equal to our income, that is P1 W1A plus P2 W2A. So from this equation, we is using this value in this one. P1 X1A, and we are proceeding later. So after doing all the calculations here, we can find that X to A, the value of X to A, that means the demand for good to Wallachian demand for good to consumer A.
Yeah.
So this is our demand for good to A. So the value of X to A, we are plugging it into the equation 1 and getting the value of X1. Okay, clear? Eva, can you
Yeah,
understand it?
we have to put the value of X to
This is our normal calculation.
it. Yeah.
Then we find, ultimately we find the X1A, X2A. This is the gamma into 2P1 plus P2 divided by P1. And for X2A, this is 1 minus gamma into 2P1 plus P2 divided by P2. Okay? So
Yeah, I understand.
manner, we can also derive the Wallachian demand for consumer B. Just put a little attention on it. UA and UB is basically the similar function, just the X1A and here the X1B. Just the notations are changed. So we can easily, directly, I can write that both are same. Actually, their MRS are same, just changing the endowment.
Yeah, right.
Or if you want, you can independently derive for consumer too. If you have a lot of time, you can do it. But after practicing multiple problems, I have seen that both just same, just changing the endowment we can get for consumer too. So I directly write.
Yeah, no problem. We can directly write that. This
Yeah,
much
yeah.
explanation doesn't need.
Doesn't change. All the calculations are same, and the functions are almost same. Just we can change the endowment and get the answer.
Yeah.
Okay, so our first problem is done. What's your comment? Is it easy or tough?
Well, it was easy and it was a shortcut method, so we can do it easily and shorter time.
2 or 3 minutes it will take. I hope this question.
Exam friendly solution, I must say. Yeah, we can proceed to question B.
Proceed. Question said that choosing good to as boomerang, graph the excess demand for good one as a function of P1. So we need to first find the excess demand. I hope the excess demand. Yeah. So from A we get our Wallachian demand for both good for both consumer. So in this demand we are putting our value price of, so sorry, I think this is not QI, it will be
P2.
yeah.
Right.
So P2 P1 after rearranging this, writing after P2 is equal to 1, we get this.
Yeah.
X2A amount to 2 plus 1 by P1. The P2 is 1. So we can derive the demand, our total demand of good one minus total endowment of good one.
Yeah.
We get the demand from question A and the endowment was given in the question. So after doing the calculation, here is our excess demand function, which is the function of P1. So using this function, we can plot this graph. The figure will be like this as in the picture. So we can fix the value of gamma at different values. Like I can use two values, gamma for 0.5 and gamma for 0.75.
Yeah.
So for these two gamma, we find the excess demand function like this. Here for gamma is 0.5. The excess demand is 0 when P1 is 0.6. That means if the price of good one is 0.6, then the market of good one clears. There is no excess demand.
Yeah.
Can
So,
you get this?
yeah.
And again, when the gamma is 0.75, we are increasing the value of gamma. The P1 also increases and the market now clears at 1.8. Okay. That
Okay,
means,
I guess
what-
your connection is very weak.
so can you hear me now?
I can hear you, but your talks is not understandable.
Sorry, this was network interaction. Can you hear me now?
Yeah, I can. Yeah, carry on now.
So where have I missed? From which topic you cannot hear me? Can you please say?
Um,
Figure. Do you understand the figure?
yeah, I understand the figure.
So I take two values of gamma and plot where the market clears. That means for gamma is equal to 0.5, when the price is 0.6, then the market of good one clears. That
Yeah,
means there is no Z1 is equal to 0.
yeah. So there is no excess demand of good one.
The curve is intersecting the x-axis at this point, 0.6. And when I am increasing the value of gamma is equal to 0.75, and the price of market clearing price is also increasing.
Yeah.
1.8. Before it was 0.6, now it is 1.8. That means
So we
whenever
can
the
say that
parameter,
whenever the parameter increases, then the price of good one also increases.
the demand for good one is increasing, the preference is increasing, so the price
Yeah.
is also increasing.
Yeah.
That why the curve is shifting in the right way.
Yeah, understood.
This graph is also the Cobb-Douglas preference. This IC is looking like the Cobb-Douglas normal look. Now I am going to the problem C. This is the problem C is asking to calculate the competitive equilibrium allocation and verify that this is the point where excess demand is 0. Am I audible, Eva? Can you hear me, Eva?
Yeah, I can hear you. Yeah, carry on it, please.
Okay. Now, competitive equilibrium allocation is the allocation where market clears. Demand is equal to supply. We know the basic.
Yeah, I know.
Yeah. Yeah. Now I am putting the excess demand is equal to 0 and doing the further calculation and find that P1 is equal to 3.5 in 3 by 5 into gamma by 1 minus gamma.
Yeah.
So this value of P1, I am putting it into the Walrasian demand that we have found in part A or part B. So after putting the value of P1, we have find that X1A, X2A, gamma plus 5 by 3, gamma plus 5 by 5. Okay.
Yeah.
Now the demand for good 1 and 2 for consumer B. After putting the value of P1, so we have found that 10 minus gamma by 3, 10 minus gamma by 5. Okay.
Yeah.
Now this is our competitive equilibrium allocation. Now we have to verify that that's the market. Demand for good one is equal to supply.
Yeah, we need to
Okay.
prove it, right?
That the demand for good one for both consumers and find it is equal the total endowment of good one.
Okay.
For B, hence our competitive allocation. So that's all of my part. I think you get it.
Yeah, I wrote it. Though your connection was weak,
Yeah.
but I have understood that.
Okay, okay.
So should we proceed to my part?
Yeah, of course.
Okay.
Stopping. Okay. Thank you, Eva.
Okay. Okay, can you see it?
Yeah, I can see it.
Okay, just a second. Okay, my problem is from chapter 6, social welfare function. And my problem is 6.3. Well, I would like to read out the question first so that we can understand the question. And so here it's said that what is liberalism? It is individual I is said to be decisive in the social choice between X and Y if X is strictly preferred to Y by individual I.
I can,
Implies that X is socially preferred to Y. Lucy, can you hear me?
your
Hello.
words are breaking. I think due to the internet connection.
Mm, yeah, but can you hear me now? It's clear. Hello, Pichi.
I think your connection was a little bit poor.
Is it okay now?
Hello, Ibra?
Is it okay
Yeah,
now?
it is okay.
Okay.
Yeah.
Well, then Shen 1970 interprets liberal values to imply that there are certain social choices over which each individual should be decisive. For example, in the social choice between individual eyes reading or not reading a certain book, the preference of individual eyes should determine the social preference. Well, here Amartya Sen gave his example, but we won't include it here. Thus, we can view liberalism as a condition on the social welfare relation, requiring that every individual be decisive over at least one pair of alternatives. Shen weakens this requirement further, and that every individual be decisive over at least one pair of alternatives. So here, minimal liberalism is denoted by Elster there, which said, which said there are at least two people, K and J, and two pairs of distinct alternatives X, Y, and Z, W, such that K and J are decisive over X, Y, and Z, W, respectively. Well, I would like to add some more things here. Okay, let's see the question first. Where is asks that prove that there exists no social welfare relation that satisfies the condition U, WP, and L. And here U is unrestricted domain, WP is a weak Pareto principle, as you know, and L star means minimal liberalism. So we would like to introduce the liberal paradox by Amartya Sen, which is also called Shen's paradox, which is a logical paradox proposed by Amartya Sen, and that shows that no means of aggregating individual preference into a single social choice can simultaneously fulfill the conditions of this tree. That unrestricted domain. Okay, then now I will explain the conditions. Our first condition is unrestricted domain. Here it is said that the domain of social welfare function includes all possible entuples of individual preference. That means that we have to take all the preferences. Doesn't matter that if it is insignificant or it is too small. We have to take all of them. And the second condition is weak Pareto principle. If everyone prefers any X to any Y, here X and Y is a pair of alternatives or commodities, then X is socially preferred to Y. And okay, sorry. Yeah. And we can see that the minimal liberalism is already described earlier. Now we'll
I can see
proceed to the
that.
proof.
Okay.
By minimal liberalism, there are at least two individuals, as the question said, that K and J, and two pairs of alternatives, WZ and XY, where W is not equals to Z and X is not equals to Y. That means the commodities or the alternatives are not identical. So,
Yeah.
here W is preferred to
Person
Z
K.
by individual K, then W is preferred to Z socially, and vice versa. And the same thing would go for individual J. If X is preferred to Y by individual J, then X is then X is socially preferred to Y. So we have this kind of preferences which satisfies you. Now we'll see the individual preferences and social preferences. The first table represents the social individual preferences by K and J. So here the individual K prefers X to Y and Y to Z, and then Z to Y. Sorry, X to W, W to Z, and Z to Y. And the individual J prefers Z to Y and Y to X. Yeah. And here, so we have X is preferred preferred to Z by individual K, and Y is preferred to X by individual J. Now we'll see the social choice. Here X is socially preferred to Z, and Z is socially preferred to W, and then W is socially preferred to Y. So we have finally that X is preferred to W socially, and Z is socially preferred to Y for all S including J and K and J. And here now by minimal liberalism, we have W is preferred to Z and Y is preferred to X. And by weak parity principle, X is preferred to W and Z is preferred to Y. Can you see the screen?
Yeah, sure. I can see that.
Okay.
Now,
okay. By aggregating these preferences, we got W is preferred to X and Z is preferred to Y. Again, Y is preferred to X and X is preferred to W. Well, here comes the contradiction that the W is preferred to W. So as we know that W can be preferred to W itself. So that's why this example implies that we can, we cannot have the U, WP and L star together. So can you,
that's so easy.
You understand properly, right?
I can understand.
Can you say something regarding this?
Oh, this problem seems that you have proved it by using the contradiction.
Yeah, right.
The paradox theory.
Yeah. And so in this example, the social choice function satisfies minimal liberalism at the expense of Pareto optimality. So because of this, it is said that, and we can also see that the society cannot have minimal liberalism and the Pareto optimality at the same time. Because one is said that we have freedom and everyone should have the freedom of choose their choices freely, but Pareto optimality opposite that, the freedom can be equal to Pareto optimality or social optimization.
Okay, okay.
Can you understand it properly?
Yeah, if I can understand it. The graph was very informative and very clear to understand this.
Okay,
I
then
think I'm going out.
yeah, right. Okay, I will then stop the sharing.
Okay, you can.
How was it?
Okay,
I
Eva, I
mean,
think our two problems now back to us.
yeah. If
Hello?
you have no problem, then can
So
we end it here? Do you have any
yeah,
question?
sure. Okay, Eva?
Okay.
No, I have no question.
Uh, sorry for my poor
So
connection.
good.
Sorry for my poor connection, the inconvenience.
Um,
My network is still unstable. Okay, then let's take a break.
okay.
Let's end it here. Bye.
Then I say, Eva.
Bye.